Hello guys, now I am going to solve the problems on triangles in mathematics of class 10. This is exercise number 2.5, 7th problem. Well, I am going to read that problem for you. Okay. Prove that the sum of the squares of the sides of a rhombus is equal to the sum of the squares of its diagonals. Okay, we need to prove that the sum of the squares of sides of a rhombus is equal to the sum of the squares of its diagonals. Sum of the squares of its diagonals. Well, before going to prove this statement, let's consider, we need to know what is a rhombus, right? Well, we know what is a square. Okay. Square, and we need to know what is rhombus. Rhombus is nothing but the distracted square. Okay. This is nothing but rhombus. There are many similarities between rhombus and square. Both are parallelograms, and all the sides of these two figures are equal. And in both figures, the diagonals intersect at 90 degrees. Okay. In both figures, the diagonals of the rhombus as well as the diagonals of the square intersect at 90 degrees. And then the main difference is the length of the diagonals differs between rhombus as well as squares. In squares, the length of the diagonals remains same, but in rhombus, the length of the diagonals will change. Okay, let me prove this statement. Let me first consider a rhombus. Okay, proof. Consider a rhombus A, B, C, D. Okay. Let us consider this as a rhombus. Okay, it's looking good. A, B, C as well as D. And this is the point where the two diagonals intersect. AC and BD are the diagonals intersecting at point O. Okay. And this will be 90 degrees. I need to prove that sum of the squares of sides of a rhombus. What are the sides of a rhombus? I have AB, BC, CD and DA. Sum of the squares is nothing but AB square plus BC square plus CD square plus DA square. Okay, this is nothing but the sum of the squares of the sides of rhombus. This is equal to sum of the squares of its diagonals. The diagonals are AC and BD, right? AC square plus BD square. This is the statement that we need to prove. Right? Okay. Let me prove that. I have AB, BC, CD, DA, but all are equal, right? AB, BC, CD, DA, all are equal. I'll consider only one side. Means if you have only one triangle, then that's enough. Okay. In this triangle, if we apply Pythagoras theorem, therefore let me first consider this triangle. Consider triangle ABO. Okay. In this triangle, the hypotenuse is AB and the two sides are AO as well as BO. Okay, AB square is equals to AO square plus BO square. Okay, this is a Pythagoras theorem if we apply according to by Pythagoras theorem. Here we can write as by Pythagoras theorem. Okay. Now what I will do is, this is AO, right? AO is this one. In a rhombus, the diagonals will bisect each other in equal parts. Therefore, this will be equal to this one. Means AC is nothing but AO plus OC, right? Since this is a rhombus, the diagonals bisect equally. Therefore, AO will be equals to OC. Therefore, I can write this as 2 times of AO. This is nothing but, it also implies that AO is nothing but half of AC. Okay, I think you have understood until here. AC is nothing but 2 times of AO and AO is nothing but AC by 2. Okay. In the same way, we can also say that BO is equals to half of DB. DB by 2. Okay. These two statements we will be substituting in this. In this one we will be substituting this statement as well as this statement to get the required expression. Okay. I think you have understood until here. Okay. Now I consider this statement AB square is equals to AO is nothing but AC by 2. I will substitute over here AC by 2 whole square plus BO is nothing but DB by 2. DB by 2 whole square. We will be getting as AB square is equals to AC square by 4 plus DB square by 4. If we take the LCM, since we have 4 as common in the denominator, we will take this LCM as 4 and send it to the LHS side. We will be getting 4AB square is equals to AC squared plus DB squared. Right? See, we have got RHS part of the equation to need to be proved. Now we need to find only the LHS part. 4AB square we can also write as AB square plus AB square plus AB square plus AB square. Right? Just I am splitting the terms, that's it. We know that since it is a rhombus, all sides will be equal, right? AB will be equals to BC, BC will be equals to DC, DC will be equals to DA. Therefore, instead of second AB, I will replace it by BC. Instead of this one, I will replace this by CD. Similarly, this one as DA. Hence, the statement is proved. Okay. Thank you.